All right, everybody, we are going to now look at axis of symmetry. Axis of symmetry has some really cool little shortcuts that we can take. So we're going to start out with some graphs, and we're going to look at how to figure out the axis of symmetry given a graph. And it's pretty basic. We can do this really pretty easily. But then we're going to actually figure out the shortcut, because what are mathematicians all about? They're about efficiency. So we're going to be looking at that efficiency and figuring out how we can make our lives a little bit easier. First of all, axis of symmetry. There's always going to be an axis of symmetry. That's that reflection of each parabola. That's always going to occur for every single parabola that you create. Sometimes you have to work really hard to find that axis of symmetry if you're given an equation. And you just only have a tool of creating a table. That can be really, really difficult. So we're going to look for that shortcut to make our lives a little easier. Right now, we're going to start out with a couple of different graphs. We have two graphs here. One's a one solution graph, one's a two solution graph. And we're going to look at how we can use those graphs to help us out. Now, in this one solution graph, our axis of symmetry and our vertex are essentially lying on the x-axis, which is really awesome. It doesn't always happen like that. It's actually really rare that it does. This is like that whale sort of breaching and like getting some water. We can say like, ooh, here's its blowhole. It's getting some water. Yay! Or air. It's not getting water. Oh my gosh, it's taking on water. That's horrible. The whale's dying. All right. So no, the whale's breathing. It's breathing. It's great. I know you guys are all laughing right now. All right. So this whale is breathing. It's going through, or we have to identify the axis of symmetry. Its axis of symmetry is just where it crosses on that x-axis, but it's also a line of reflection. You always need to think about it being a line of reflection. And when we are actually graphing that, or when we're actually labeling it, I want you to always write axis of symmetry, and then you're going to write an x equals equation, because x equals equations create that sort of vertical line if we don't have any other variables. So our x equals equation is x is equal to 2 in this case. Axis of symmetry is just right there. It touches the x-axis. It's great. Awesome. So what can we use there to help us out? Well, we can see that our vertex and our axis of symmetry are going to have the same x value on there, which is killer. That's awesome. And that can help us out with one solution graphs. Now, what if this was shifted up and that point was not actually on the x-axis? Well, then our vertex isn't on the x-axis. That's fine. But essentially, we can just look at that and identify where it's graphing. If it's shifted up, though, or shifted down, we're looking at a situation where we have two solutions. We have two roots. We have two zeros that we can look at. In this case, we can see that our zeros, I drew this super accurately, people. This is truly 5, 0. Don't judge me on my drawing. And this one is 1, 0 for our roots. And actually, I'm going to write this on the other side over here so it's not in my way. So we have 1, 0 and 5, 0 for our roots. And we can say like, okay, great. I'm going to use those roots to my advantage and find my axis of symmetry. My axis of symmetry is always going to go right in between those roots every single time. We can see that our axis of symmetry is x is equal to 3. So if that is our axis of symmetry, we can look at our roots and see, okay, here's my x value of 1 and my x value of 5. What's exactly in between 1 and 5 on a number line? 3. So we're just looking at taking the x value of our roots and finding the average of those things. So 1 plus 5 is 6. Divided by 2 gets us 3. So that's our axis of symmetry. It's kind of neat. We can look at just the roots and say, oh, divide those by, or like add them together, divide by 2, find the average of them. And that's my axis of symmetry. So if you have the roots already figured out or whatever, and you don't actually want to graph it, if you have like a table of values of say like, oh, I have this table of values of 1, 0 and 5, 0. Oh, there's my roots. That's awesome. What's my axis of symmetry? Oh, if these are my roots, I'm going to find the average of these numbers. Isn't that sweet? Mathematicians like efficiency. There's some efficiency for you right there. Here's some more efficiency. So if you didn't even want to graph something, if you didn't even want to create a table, you can start to actually figure this stuff out just given your equation. It's kind of killer. All right, so we have this equation right here. Y equals x squared plus 3x plus 4. Finally, we have a b term in here. We haven't been dealing with that very much. B terms cause us to shift left or right with our parabola. Wow, I can't talk. Left or right with our parabola. And because of that, we have to be really, really thoughtful about how we're using that b value. So we have this as our standard form of equation, y equals ax squared plus bx plus c. We know that if we had our roots, we could find the average of those, and the average would give us our axis of symmetry. Our shortcut is kind of neat. We can take some of the aspects of this equation and generalize it and turn it into this. So here it is. Our axis of symmetry shortcut is this. I'm going to take my negative b value. So if my b value is already negative, I'm going to turn it positive, right? I'm going to take the opposite of what it is. So I'm going to say my negative b value over 2 times my a value, all right? So I'm going to take whatever number I have in the b position and divide it by 2 times whatever's in the a position, or negative b over 2a. All right, so that's my axis of symmetry equation. Let's check it out. My a is equal to 1. It's that hidden 1 right up there, right? There has to be a 1 there, otherwise there's not a term. And my b in this is 3. So if I were to put that, I can't write 3s today. All right, so I'm going to put that then into this equation. X is equal to negative b over 2a. I'm going to put that in there, and I'm going to say, okay, my b value is 3. So instead of writing that, I'm going to write 3. And my a value is 1. So now I can solve that. Negative 3 over 2 times 1. I can simplify it to negative 3 over 2, or you can even say negative 1.5. But you know me in fractions. I like those best, so I'm going to say negative 3 over 2. All right, so my axis of symmetry for this equation, shortcut style, is negative 3 over 2. And truly, the reason why that works is because they're going back to this concept of the roots and taking the average of the roots. But at the same time, I'm going to just throw that out there. There is your axis of symmetry sort of shortcut. If you want, you can still totally do it based on graphs. You can still totally do it based on roots. Pretty soon we're going to be working with factoring, so we're going to find our roots really easily. And we're going to be playing around with other ways that we can find our roots. But if you can graph something, find the roots and take the average of them, or you can use this equation, negative b over 2a. You can find the axis of symmetry really easily. So big idea of toolbox. Let's add a little bit. Axis of symmetry. Axis of symmetry is that line of reflection. Line of reflection. It always needs to be written as an x equals equation. So our ways that we can find it are take the average of the x values or roots or solutions and write x is equal to a number. And you could also use our axis of symmetry equation, which is x is equal to negative b over 2a, remembering that we have this as our base equation, ax squared plus bx plus c. C. Okay, so we can do that. Our line of reflection that we're always going to draw is always going to be a dashed line. We don't want to make it a solid line because we don't want someone to think that this is truly part of the graph. I mean, it is part of the graph, it's part of the structure of your graph, but you don't want that dashed line to be seen as like values of the graph. It's truly just, we're just saying this is the mirroring of our graph, and our graph is truly just the parabola. This is the mirroring of it. Anyways, big ideas, axis of symmetry. You can average the roots, or you can use this awesome equation, negative b over 2a. Have fun.